Hi! In this video I want to talk about this over-engineered piece of audio equipment. Specifically, these are 3D printed epoxy gravel composite filled speaker housing for my car, Volkswagen Multivan T5, and those are suited for 165 diameter woofers. The obvious question is why I build them and not just buy one available on the internet made out of MDF, let's say. And the answer is that I already have those installed in the car exactly on those MDF housings, and after 2 years one speaker just stops playing, and I was investigating why, and after I opened the car door I find out that the housing just swells and disintegrates due to the humidity in the car door and due to direct contact with the water droplets which was dripping from the ceiling of a car window. Unfortunately, as it drops and the speaker completely falls off, it falls onto those two contacts and shortens the circuit and blows up one channel of my amplifier completely. So I don't want to risk it again, so the option of buying another MDF one was not an option at all. Then I've got 3 remaining options. First one is to remain in silence, but all of my family loves music, and if there is no music at all, then our rides look something like this. Well, sure, this is cute, but after 2 hours of riding in these conditions, you have this size of head. So this is not an option. And the second option was to buy a plastic one. They are available for my car on the car hi-fi stores and shops. But the problem with them is that I do not trust that they will sound great, because if you think about a speaker housing and the requirements for the material it should be made out of, then there are actually 2 main requirements it should meet, and one is the weight, and it should be as heavy as possible, and the other is the vibrational dampening parameters of the material. And the thin plastic, I think, will resonate and vibrate and is not heavy enough to support, those low frequencies kicks. And therefore I came with the idea to just manufacture one. I have the 3D printer, I have some kind of manufacturing knowledge, can design things, so I start messing with this idea, and well, the reason why I choose the gravel and the epoxy as a filling material for this is because the composite materials have those dampening properties. As the shock wave travels through the material, then on those edges between 2 different materials, the waves just dissipates and transforms into heat. So that's why the composite materials are great, and some really well-known established hi-fi brands use epoxy resins filled material for their high-end speaker sets. So I think this would be great. Well, in this video I want to talk about, okay, this was the motivation, but I also want to cover the design choices I have to make during manufacturing of these, and also some actual process of pouring them and some pitfalls and problems I have to overcome, and maybe what I will do differently in the next builds. So design choices. As I mentioned, I want them to be heavy and to be dampening, vibration dampening. So I achieved that by choosing the right material, as I said, and this is the gravel I have to choose. Actually, this is originally made for aquariums. By just looking at them, it just probably has grains of sizes from 0.1 to 0.5 millimeters. And it went in quite well without any problems. And the epoxy I choose was this one. It is Speed 10. I'm not sure if it's available in our country, but I just have these on stock, so I just use this. This one is quite low in viscosity, so I thought that it would just be looking into those cavities around better. I also designed a little slots here for the nuts, so the speaker itself can be mounted with M screws and doesn't have to be, drilled or glued or something like that. And also I designed this skirt here, lip, or how to call it. This is for the water. If there will be some leakage into the door and the drops starts to fall onto my speaker, I don't want them to destroy the actual speaker. So I designed it that this can be positioned in many ways in the door. That's why there are so many slots here. And so this will face downwards, and every drop of water will be guided down and drip from this dripping lip here. Also, it is designed so it doesn't interfere with the speaker, but it is close enough to not interfere with the car window which is traveling behind it. And if eventually it will make contact with the window, it's made out of TPU, so no damage to the speaker housing or car window either. I have 2 times the amount of hole needed for mounting this speaker, and that's because the grill itself will go on top of it. I'm not sure if it's necessary, but I got them and they look badass, so I just decided to utilize them. But it doesn't actually matter because this is not a part which will be visible in my car, therefore also this caulk here is not an issue at all. Okay, that's probably about a design. Let's talk about how I actually made it, so follow me into my computer. So for the actual 3D model, I designed it as a multi-body part. So everything is in one file. This is not an assembly, but a multi-body part, which I have then saved individually as STL file. So first of all, just have a look at this body, which is made out of PETG. The main feature is just a cylinder, from the dimensions I have measured on my car. And I decided to put a multiple groove-like slots around because I'm not exactly sure about circumference of the holes in the car. So this way I have some freedom to, just position it as needed. And also, as I have there this skirt, which has to be positioned this way so the water can just flow down, and I'm not exactly sure where the holes will fit, and so I have to rotate it on the place. So I designed a multiple holes around the circumference, so I'm sure that it will fit the way I want it to. Then actual mounting of the speaker is done via M5 probably. Let me just see it real quickly. M4 screw with a nut inserted inside. And I have concerns about the epoxy, which can fill this hole up. So I will show you how I managed that.
on actual part. And also I designed a screw mount for this skirt here with M3 and a nut, but this one was never actually used because it turns out that it fills out with epoxy, and it was easier to just plug some wood screw inside and it holds perfectly. This looks like final model, but I have also the version with this pouring, cones here to fill epoxy in. And as you will see there, I designed it as a full part, and the inside will be hollowed by decrease of infill while 3D printing. And while I was designing it, I have some concerns that while I'll be pouring the epoxy inside and the epoxy level reaches somewhere there, then this part here, which I will draw in blue, will have troubles to be filled with epoxy because of the air trapped inside. And the way I tried to mitigate this problem was I start to pour epoxy just on one cone here, wait for it to sink down, and then continue here, and then add another two, and then work my way down to the bottom one. So that way I hoped that it will just, flow around and the viscosity of the epoxy isn't too high, and it will just flow inside of these cavities as well. It turns out that it wasn't the best approach I could have choose, but it kind of worked. I will show you on the actual part later on. But for now, let's stay in the 3D model and have a look at skirt. Skirt. It was kind of tricky to model it, but not very much. I made it out of TPU, and this is the place where it sits on the printing bed. Firstly, I have designed it to be, this shape, like S shape, and I didn't realize that there is no support, and I printed without support, and the first try it came out completely messed up, so I have to remodel it and print it again, and then it came out quite okay. And this is not the visual part. You will never see this part in a car. It is embedded in the actual door frame, so no need to be really beautiful. So I sealed it all the way with some glue and so on. It just have to perform good. And I also add some washers here and under the speaker just to better enhance vibration dampening properties of this part. This is okay. That's all for the model part, and let's have a look at 3D printer settings. So as I said, I have chosen the PETG. The PETG is good because when epoxy is curing, it heats up, and I was not sure that with this volume of epoxy how much hot it gets, so PLA might be a problem here because it deforms at about 60 degrees Celsius, so PETG was a better choice for me, and also it prints very nicely. So if I just leave it on 0.3 draft settings and just slice it, you see that it chooses rectilinear infill, which is not very good because obviously the epoxy has no place to flow in. It will just stays in one pocket, so I have to change it to jury is perfect for this. I don't remember exact number of infill volume I have chosen, but it was probably somewhere around 5% maybe, because it don't have to be really dense. You have to make sure that all the grains of the gravel will, you know, shake inside all the parts of this interior. So probably 5% is okay. And I have a problem with this upper face, which is not hollow. I could just drill it after printing, but I decided to, you know, add some modifier. Add modifier cylinder. I position it on the place inside of this cone. Okay, I will do it quickly just to show you how I made it. I have it over printed, so I don't need to do it precisely like that. Oh, I moved it. And now you can see why I have to cut the sides of the part. I probably didn't mention it already, but my printer, Prusa IMK3 Plus, just don't have enough space on the print bed to print it as a circle, so I have to cut it, but I don't think it will be any problem. Okay, so this one, and give it a settings. Top solid layers. Okay, and I will crank it down to, okay, 0. Slice now. Okay, and you see that there is only a bridging here, which is a really thin layer of material, which I can live with. I just need to drill it. But I'm sure I will not damage the cone itself. If there will be too much material, the drill bit can just, you know, slide around and make some holes here and there. Okay, so this is the print setting I have chosen. No supports at all. I just, you know, press the nut inside without any problems. So you can see that the print time was 6 hours 47 minutes. Not so bad for this big part, and 0.3 is enough to just, you know, speed things up and also to, you know, keep the shape. Also, I have problem here because, as you can see, the tool path is outside of the print area. That's because of this brim around. Okay, it's not brim, but it's skirt, brim, outer. It's a skirt, so I put it on 0, and now we have no problems at all. Okay, so then I multiply this cylinder. And I slice it and print it, and turns out great.
Okay, so now how I actually made those. Well, the 3D printing part was easy. There was no problem at all. Then filling the gravel in, it requires some, you know, bashing, smashing, and general, you know, settling the things up. But actually, finally, I think it distributes quite well and evenly in the volume of the part. And this is the table I was actually working on when I was doing those. Now I have some other projects running here, but after the pouring part comes, then starts the problems. As I mentioned at the cut part, I was thinking that by pouring epoxy just into one cone, letting it set will be enough to, you know, fill all those cavities here on the outer ring. But it shows up that it wasn't actually the case, because once I start pouring it on the one, that it just doesn't go inside as well as I thought it would be. it takes too long to, just settle in, suck in. And I start to be nervous because I have only about 20 minutes before it starts to cure. So I start to be nervous, and it starts pouring the epoxy into those other cones. I try not to pour it all the way to all of them, so I leave 2 or 3 left on the bottom, but it's still, I cannot see any epoxy raising through those holes. I was expecting that if it lies flat and I will be pouring 1 only, then it will fill out evenly, and it will raise, and eventually I will be able to see it on the other holes, but it just doesn't happen. And I was doing both of them at once, so I'm pouring 1, 2, 3, and so on. And eventually, after a couple of minutes, I start to be so nervous that it just starts to cure before everything fills up. So I pour it everywhere and hope for the porosity of the 3D printed material to work for me and just, leave the trapped air here, which probably works because finally I got leakage of the epoxy everywhere around that part. I kind of expected that, but not in that volume. And after some investigation where it leaks, I found out that there were spots where it just doesn't go through. So I drill a bit of holes here and there just to make sure the trapped air will come out and epoxy will fill it. Then I leave it like that in a big puddle of epoxy, and I have to leave the office because I have to go for the kids to the school. On the next day, I found out that the cones which I left completely filled has sunken a little bit. That's probably a good sign, because when epoxy is curing, it shrinks a little. So there was a reservoir of some material which can, which can be dragged into if needed. But the part was also sticked to the table terribly. It takes a couple of minutes to chisel it out. And then the cleaning of the part itself was kind of easy because epoxy doesn't stick to plastic at all. And one thing I didn't mention is that the material I choose was PETG, because when epoxy is curing, everything heats up, and I was not sure how much it will heat up, so I just bet to be sure on the PETG, which can withstand like 90 degrees Celsius with ease. One thing I was really concerned about when pouring the epoxy inside was if the epoxy leakage from the pores of 3D print will not block the threads of the inserted nuts. Because these things happened to me a while ago when I was designing not this kind of product, but something similarly made. And therefore I was aware that it will leak somewhere. And once it cures, you cannot just unblock the threads of the inserted knot, and if you try to tighten it with force, you will probably make the knot spin around and you completely ruin that one hole. So what I actually came up with was I dip the screw into Vaseline actually and screw it inside of those nuts and pour it with the screws inside. Therefore, if the leakage came out, it won't go to the threads because of the Vaseline, which was greasing the inside. And it quite works. I have no blockage of the thread at any of those nuts, and there are quite a lot of them. What I have blocked with the leakage is the M3 holes I have designed here. So I just replaced them with these wood screws, and it just works kind of well without any problems. Probably in the future I will be designing them like so. It's too overcomplicated. In conclusion, there was things which I will definitely do differently if I will making it again. I'm not sure if I will have to, but if you listen, you can hear that there is some spots inside which are not poured with epoxy. I'm not sure if it will, some kind of interfere with the music experience, with listening experience I will have. We will find out after installation. If so, I have few ideas how to achieve better results. Those cones here doesn't work as expected, so I will dump them and instead use the pouring holes in this side, maybe 3, maybe 4 of them. On the other side, I will drill or design ventilation holes, and I have a vacuum pump available. I use it for removing bubbles from the epoxy and so on. And I think if I will be able to wrap this part into some plastic bag, really, like a heavy one, and somehow plug the tube inside, vacuum this thing up, and on the other end there will be a reservoir with epoxy already mixed. Then when the vacuum will be here and I release that epoxy, it should nicely fill all that vacuumed parts and just leak from the other side. And if I let it cure like that, then it should be definitely better. I'm not sure if this will work, but I think it will. The problem is how I will attach those tubings into plastic bags. I am sure I can figure something out, and maybe something is already available to get. And so that's all for now. See you in the installation. I hope you find this kind of informative and maybe inspirational, I don't know, but I definitely like to share it with you. So stay tuned, I will be mounting them in the next episodes, and see you later.